Continuing with video number 2. For these other questions on determining the domain and range from the graph, if the previous explanations on video 1 didn't help, remember also that you have access to the help videos, which are rather useful. I consider these help videos pretty good explanations most of the time. And then this domain and range, let's go ahead and practice this one together. As you can see, we're going from -2 to +3 on the x-axis. It's really helpful just to identify where you are on each axis. So the farthest to the left you can go is -2. The farthest to the right you can go is +3, noticing that there's an open circle here at 3. And then this tells us that the domain is going from -2 to +3. And let's go ahead and type that in. There you go. And then the range, similarly, we are going up and down on the y-axis this time. So we have from -5 with an open circle all the way up to 4. Now there's not a closed circle here, but because this is actually an included point, any point is included unless it has an open circle, then we have a solid dot here. So we're going from -5 to +4, not including -5. And so we end up with brackets on one side of each interval and parentheses on the other side of the intervals. All right, now for the domains and range of the toolkit functions, these are the basic functions. Toolkit functions is another way of saying parent functions. They're the basic functions that you are going to want to learn about. And if you flip over to the book, in section 3.2, it actually shows you pictures of every single one of these toolkit functions with the domain and the range included. So you have your flat line, your normal line, the identity function is y equals x. You have your absolute value function, your quadratic function, cubic function, reciprocal function, reciprocal squared function, all these different functions. They already list out the domain and the range for you so that when you're in MyOpenMath, you can simply match up the picture to the equation, as well as provide the domain and the range. So these are not going to be random. These are going to be you going back and forth between the textbook and looking at the particular pictures, seeing what the corresponding equation is, looking at the domain and range, and this is just entering the information that's given to you in the textbook. So I'll do number 16 for you. In this case, you can see that we have an absolute value function. So what you could do is you could pop over to the textbook, find the absolute value function. Aha, here it is. You can observe that the domain is -infinity to +infinity. The range is from 0 to infinity. And this is what the graph looks like. Here's the function listed out. And so I'm going to draw a graph that's going to use the V here. I match the graph to the picture that's given to me in the textbook. I also match the domain to what's given to me in the textbook. And then I submit the question. So all you have to do is match up each of these toolkit functions to what's presented to you in the textbook, and that will give you the answers for each one. Okay, in the case of number 18, this one's a little tricky because we have both a denominator issue and an even root. So we want to say that any value of x is okay as long as it does not give you a problem with the denominator or the even root. So let's consider the two things that we want to watch out for. So we would say that x plus 2 needs to be greater than or equal to 0 because of the radical, and that x minus 6 cannot equal 0 because it's in the denominator. And then when you solve each of these, you see that x has to be greater than or equal to -2 which would line up with this and this so far. But then also we have to exclude number 6. Now notice this is not excluding the number 6, whereas this original compound inequality is doing so. It's taking two disjoint pieces of the interval and uniting them with the union symbol. Okay, so now we're going to next look at what are called piecewise functions. And I'd like to point out that in the textbook there are a good number of examples that explain to you how to write a piecewise function, how to graph a piecewise function, all the things that you might want examples for with explanations attached. So I highly recommend that you look through the examples in the textbook. For this number 20, we're looking at an internet plan that is going to vary depending on the gigabytes used. So there is a base cost of $70, and that includes the 30 gigabytes. Then it's going to cost another $9 for every gigabyte over 30, but up to 65. And then once you get up to 65, you pay $7 for every gigabyte after that. So what we want to do is consider, what would this function look like? Now you could start with the beginning and then go to the end, or go the other way around. I'm going to start with the end and then go back to the beginning, but it's up to you. So what we see here is the downloading function is broken into 3 conditional parts. The first conditional part says that x is between 0 and 30. The idea here is that if you are downloading up to 30 gigabytes, that you would be paying $70, okay? So regardless of how many gigabytes you download in the first 30, it's 70. Now why they have chosen to make the 30 less than only versus less than or equal to, it doesn't really matter for the way we're going to set this up. I probably would have put less than or equal to up here, but it's actually going to work the same either way. So what we're going to see here is that after you pay the initial $70, you have to pay more if you're going to if you're going to download more than 30 gigabytes per month. Well, you only have to pay $9 extra for every gigabyte after the first 30. So we want to say, how would we represent that? Any unknown gigabyte, of course, is going to be x. It tells us that right there in the problem. Well, we don't want to do 9x, because if we do 9x, that's going to tell us we're paying $9 per gigabyte for all the gigabytes and the additional $70. No, we're not actually paying $9 for every gigabyte, just the ones that are over 30 up to 65. So over 30 would be represented as x minus 30. And so x minus 30 is the over 30 gigabytes. That gets multiplied by 9, and then you had the standard $70 cost. In the third scenario, you have the standard $70 cost, and then on top of that, you paid a certain amount of money for the next gigabytes up to 65. Well, how much money did you pay for these gigabytes right in here? If you actually did download 65 gigabytes, that would have been 35 extra gigabytes, and 35 times 9 is $315. So you would have had to pay $315 for the extra gigabytes that you took from this second category. Once you get up to 65 or higher, then the cost goes down to $7 per gigabyte, and it's per gigabyte over 65. So anything beyond 65 would be represented by x minus 65. That's what gets charged the $7 per gigabyte. The 315 is from the 35 gigabytes from this second range that got multiplied by 9, and then on top of that, the $70. Now, you might need to simplify this. I'm not sure if this will be accepted in this format. Let's check. The first three I'll definitely get wrong because I didn't enter them. Well, let me go ahead and just put these in. Okay, it's fine with this unsimplified version. So how do I get these answers in the first place? You can use a certain amount of common sense to figure it out, or you can use the function itself. So in the case of 21 gigabytes falls into the 0 to 30 group. Anything that falls into the 0 to 30 group is automatically going to be 70 every single time. So that's why the 21 has to be 70. Now, when we get to 53, we'll notice that 53 is in the second group. It's in the 30 to 65 group. So if we plug in 53 to this equation here, we need to subtract 30 from the 53, which would give us 23. And then we're looking at 23 times 9, which is 207, plus the initial 70, which is 277. And then for this third number, the 67 falls into the third category. 67 minus 65 is 2, so you get 2 times 7 plus this 385, which is where you're going to get 385 plus 14 is equal to 399.